Yes, thanks to everyone for being here this afternoon, especially on a Friday afternoon. And thank you for your interest in flat-lying spray machines. So once again, my name is Doug Mounts. My email address there is at the bottom. I'm the finishing product specialist for Stiles. I handle the Southeast and the South Central regions of the United States. So let's get into the presentation if we can. So what is flatline finishing? Well, you're probably familiar with manual spray, which is probably what you have now, where you have a spray booth. You carry the parts into that spray booth, spray those parts, carry them out, put them into an oven or a rack. There's also hanging lines or cart lines where a person stands in the booth and the part travels through the booth and they manually spray the coating onto that part. And what we're going to be discussing today is the advantages and the different types of flatline spray machines. So there's different types of spray machines, but there's some common features to those machines. The first thing, the typical width, the average width of a flatline spray machine is 51 inches. Meaning you could run something as wide as a 4x8 sheet and still be able to get good edge coverage on your left and right side of the part. All machines will have some type of reading bar or a photo cell bar that reads the dimensions of the part as it's entering the machine, and in turn tells the guns when to fire off and on for the most efficient way of applying coating. Each machine will have some type of exhaust fan, and that's there to pull the overspray from the spray chamber, pull them through the filters on each side of the machine, and exhaust the overspray cleaner air outside. Each machine will have a control panel, and on that control panel will be an HMI that's easy to operate. If you want to turn the fan on, there's a picture of a fan. The conveyor, you want to turn it on, there's a picture of the conveyor, so it's really simple to use. And the exhaust filters, there's one on each side of the machine. That's what filters the contaminants, the overspray out, so it can be exhausted out. Those are pretty much similar features of all flatline spray machines. What we want to look at today is we have different types of belts. We have paper belts or a self-cleaning Mylar belt. And in some cases, the coating can be reclaimed and reused off of that self-cleaning belt. We also want to look at one-arm spray machines versus two-arm spray machines. And we also want to look at pressurized versus non-pressurized spray machines and the advantages and disadvantages for those. So first, let's look at the paper belted machine. Now, a new roll is brought to the machine that's been presented on a cart, as you see. That's placed in front of the infeed side of the machine. That paper is fed through the machine, and then on the back side, the outfeed, there's a take-up roll there, and you would take tape and attach it to the take-up roll. So when the machine is running, you're accumulating the dirty paper on the outfeed side. A little bit about paper. It's a type of craft paper, butcher paper, if you will. Typical roll is 64 inches. And yes, we have a working width of 51, but the industry standard is 64 inches for a roll. Now, depending on the strength, the thickness of your paper, they typically come with 8,000 to 9,000 linear feet on a roll. And a good tensile strength is in the 35 to 45 pound range, meaning if it was less than 35, there's a possibility it could break. And if you're more than 45 pounds, you may be spending a little bit more than what you necessarily spend because the paper is stronger than you actually need. An average cost of a roll of paper is approximately $375. Now, if we break that down in linear, it's around 4 cents a linear foot. So it's not very expensive at all. If you're running your spray machine at a line speed of 10 feet a minute and continuously running for an hour, you would use about $24 worth of paper in that hour. The average lifespan is around 3 to 4 days. And obviously that depends on how much you're using it throughout the day and the line speed you're running, and also how you are laying the parts on that paper. Are you utilizing the whole square footage of that paper surface in a given minute? So let's look at some of the pros and cons. That paper, it can be disposed of pretty much like you do your spray booth filters now. That can be cut off, the take-up roll thrown into the dumpster. In most locations, most areas, most cities, you can do that. Since it's a paper belt, there's no solvent. You don't need to clean the belt, so there's no solvent that you have to deal with, and no expense of the solvent. And at the end of the day, there's very little cleanup, meaning it's time to go home, you clean your pumps and guns. I would recommend at this point, cut the accumulated dirty paper off your take-up roll, throw it away, reattach the paper to your cylinder on your take-up roll so you're ready for the next morning. Now, there's waste, just like we talked about, that paper will be considered a waste. And one new roll, since it's wound tightly from the factory, it will give you approximately 3 dirty rolls that will accumulate. They're dirty. We can't roll them up as tightly as they do from the factory. So that's what you'll have to discard and cut off at the end of the day. So installation and deinstallation of those rolls will take approximately 10 to 20 minutes, depending on how many people's helping. And those rolls are heavy. You may require a forklift to place those on that cart. 2 strong people, guys can pick it up and put it on there, but keep in mind some handling of the paper there is involved. So now let's move on to self-cleaning belts, or the reclaim type of belt. The pros and cons of those: with a self-cleaning belt, you don't have to stop, change paper, so you can run in a continuous mode. You don't have to stop and replace the paper. We mentioned reclaim a couple times. Reclaim on non-catalyzed coatings is a possibility, especially if it's water-based, let's say. And we can, that first initial scrape, as we're cleaning that belt, we can collect that into a container, restrain it, and use it back into the bucket you're pumping out of. So there's a chance to save some material there. It's not always the case, but there is, in some instances, you can reclaim and reuse some coating. Now, this is ideal for higher volume production, since we don't have to stop and replace the paper. Some of the cons: we've got to use solvent to clean that belt. And obviously there's cost associated with the purchase of that solvent. If it's $10 to $12 a gallon, or whatever solvent you may be using, there's cost associated there. That solvent, once it's dirty, once you've used it, you can't just throw it away. You've got to put it in some type of drum or something and have Safety Clean or some company come to dispose of it for you. So there's some cost associated with that. Now, that belt will have to be changed at some point, depending on what type of coating you use. If it's a pigmented coating, let's say a white primer or white color coat, that titanium dioxide in that material, that pigment is abrasive, and it will tend to wear a belt a little faster than if you were using, let's say, a clear sealer or clear top coat. But on average, from 1 to 3 years of needing to replace the belt. Here's a good example of what happens. The spray machine starts spraying. You see the scraper is automatically engaged. There's where you could reclaim that product, collect it into a bucket, and reuse it if that product is reclaimable. So we've done the initial scrape. We've gotten probably 90% of the material off the belt. The belt will continue down, and a roll will apply solvent, and then we scrape that one more time. So that's 2 scrapes. But we also apply more solvent and scrape it a final time. So each revolution of that belt, we will get a clean, dry belt. There's where the 6 gallons comes in. Now that solvent will be drained down into a container. We can try to separate some of the heavy sludge out and pump back as clean as possible solvent back into the system, so it's a continuous loop. And there shows the container where we're separating the solids and pumping from the top. So now let's move on to spray machines, one arm versus a 2-arm spray machine. If you'll notice on the 1-arm machine, there's 4 guns there. Those 4 guns are fixed, that they're angled in an outward direction. When you look at the 2-arm spray machine, you'll see there's 2 guns on one arm and 2 guns on the other arm. That gives you 2 guns. All 4 guns are spraying, but they're split between 2 different arms. So you may hear the word circuit or paint circuit. A circuit is 1 pump. Typically, it's mounted on the wall beside the machine, and that 1 pump is feeding 4 spray guns. Now, there's a correlation between line speed, how fast your line is running, versus what kind of stroke speed. That's called an oscillation, 1 complete back and forth stroke. So we know, let's say you're running 10 feet a minute. We need about 30 oscillations per minute of that arm, whether it's a 1-arm or a 2-arm machine. That's kind of the rule of thumb. If you want to run faster, you will need to increase that stroke speed. But typically, once we set it up, when we install the machine, there's no need for you to have to change anything. Here's a short video showing Ryan, our lab director. He's spraying some, I think it's sealer on some walnut and some birch panels. There was the reading bar. It's reading the parts, sending a signal to the guns to fire off and on. Notice that arm is same stroke speed. Those guns are the same distance from the part, and the angles are fixed. We'll talk more about that in a few minutes. But notice there's an open area on this paper belt. In production, obviously we would recommend filling that gap, load parts from right to left across instead of one behind the other. That overspray that you see, we probably could narrow that in and not have quite as much overspray on the outside of the parts. But this is a lab machine, and we keep it so we can run any different size parts. So, but in your facility, we'd probably bring that in a little tighter. We need to get good edge coverage. We need a gap between the parts. Whatever your thickness is, let's say that's a ½ an inch part, we need at least 1 inch or twice the thickness we need for gap. So those gun angles can do a good job of coating those edges. So one-arm spray machine, like I said, you have 4 guns. They're facing in an outward direction. One pump feeding those 4 guns. That's considered a circuit. Now, this type of machine is ideal for a lower speed, production speed, let's say less than 16 feet a minute. I'd say the average line speed that most customers would run is somewhere between 10 to 12 feet a minute. Here's an example of a 2-arm spray machine. You'll note that's a Mylar belt, the self-cleaning belt. And you'll notice the first 2 guns will be applying a medium coat. The panel will continue down the line. And then the second arm with the second, let's say the 3rd and 4th gun will be finishing that up. Once again, stroke speed is the same, distance from the part and gun angle. Here you'll see a really nice looking finish, uniform. Now a human could spray that well. They could spray that even on 1 panel or 2 panels. But what about 50? You know, there's a lot of variables involved with manual spraying, and we'll address that in just a second. So 2-arm spray machine, notice the guns are facing inward. Let's say guns 1 and 2 and 7 and 8 are on 1 circuit, and then 3, 4, 5, and 6 are on a 2nd circuit. So we can typically hold 8 guns on a 2-arm spray machine. Now, you may hear, well, we can put 12 guns. We can do that, but on most standard machines, we don't want that much weight on those arms. So we try to limit it to 2 circuits and 8 guns. We can add a 3rd circuit and quickly replace those guns. We have a way of quick disconnect 4 guns, put 4 more new guns back on. This type of 2-arm machine is better for higher speeds, from 12 to 24 feet a minute. We can run faster. One correlation, the faster you want to run, the body of the machine, if you want to run, plus 20 feet a minute, we need a larger body machine to help dissipate that overspray that's being generated. So let's talk about pressurization and the pros and cons of those. So pressurized spray machine will give you a much better finish. It's a much better performing machine. It gives you a lot more control of even with your overspray, the pattern of the spray as it's being sprayed out. It will allow you to direct that overspray into recesses or into sharp corners better with a pressurized machine than a non-pressurized. And one of the main goals is to keep that chamber clean on the inside. If you start accumulating overspray and that falls down on your finish, then that's a problem nobody wants. Where a non-pressurized spray machine, it's more suited for low production. You say, hey, I'm only going to run this a couple hours, 1 or 2 or 3 days a week, then that's fine. It's typically designed as a lower price point, an entry point a spray machine. So pressurized is going to give you the best finish overall, day in and day out. In both versions, you're spraying with the same arms, the same guns. It's just how the maintenance of that machine, a pressurized unit, is going to be much better for you. So let's look at it a little bit. On the diagram you see on the left, that top section is a pressurization unit. That comes with, a machine can come with or without that unit. But what we're going to do is there's fans in there, and those fans are going to pull air from the environment. And then it's going to push it through a series of filters at the top of that spray chamber. While it's going through those filters, obviously it's cleaning that air and keeping the chamber free of any, let's say if it was a non-pressurized machine, then you would be pulling air from your environment. If there's a sanding area next door or a sander, you could theoretically be pulling dirty air through your machine and putting it into your spray chamber, which, you know, we don't want. Now we can have variable speed motors on the top, those fans on top pushing the air in, as well as the fans at the bottom. Those are pulling the overspray from the chamber, pulling them through the paint filters, and then exhausting clean air outward. It's a much better setup to have pressurization. It gives you a lot more flexibility, a lot more control. So why flatline? Why should we, what is the main reasons for choosing a flatline spray machine? One of the biggest is consistency. If you remember those videos we just looked at, those arms were traveling at a constant rate back and forth. Those guns were fixed. They're in a locked position, and the distance from the part, they're all the same. And that's very important. And we'll look at why that's important. So transfer efficiency, you may have heard that term. What that is, the amount or the percentage of coating material when you spray it that's actually reaching your part. So a low transfer efficiency is not as good, obviously, as a high transfer efficiency. Now, spray angle will affect the transfer efficiency as well as the consistency of application, the spray distance, how far your guns are from your part, and that stroke speed and the overlap. All of those play an important part. And a person doing spraying, he's got to keep all those in mind when he's spraying that, let's say, kitchen cabinet door. So let's look at this illustration of a person holding a gun. If to do that correctly, that gun needs to be tilted up at a 90 degree to the part that they're spraying. But since it's at an awkward angle, that spray pattern coming out of the gun, you're going to be thick on that top side. You're going to be wetter and thicker. And at the bottom, you're going to be thinner and drier. So that's a variable that we don't want. So in the next illustration at the top left, you'll see, okay, they've got their gun at the correct angle, but they're pretty close. And when you get close, you're applying too much material and you could sag or run. You know, the finish doesn't look nice. And notice the width of that fan. It's much narrower than what it should be. And in turn, the illustration at the bottom, they're too far away. So that fan pattern is much wider, but you're dry spraying. You're not spraying a good wet film. So there's another thing that the manual spray operator has to keep in mind. Okay, he just thought about, is my gun tilted up and down correctly? Am I too close to the part? Am I too far away from the part? So that's variables. If we look at the illustration on the right, the gun in the middle, that's how you want it, nice straight. But as you start going to the left or to the right, this is showing the person is not what we call in the industry, they're not breaking the wrist, they're too stiff. So you're going to be shy on your coating on the left and right side. You'll be fine in the middle, but this is a variable that manual sprayer has to keep in mind. Okay, I need to break my wrist. I need to keep that same gun angle all the way across to the right and then all the way across to the left. Just a lot to think about. And that's why flatline spray machines, we eliminate all of those variables. Another thing, okay, I'm holding my gun correctly. I'm breaking my wrist correctly. Now I need to overlap. I'm the same distance from the part. I want to overlap 50%. There's another thing that they've got to be thinking about, which can cause some inconsistency. Flatline spray machine, all those are constant. They don't change. So in my last few slides, I just want to talk about the return on investment. As you'll see, the person on the upper left, he's manually spraying parts traveling down a hanging line. You know, his gun angle, it's a little turned. His distance is okay, but he's got to maintain that. In studies we've done, manual spray is around 30% efficient, meaning the transfer efficiency is around 30%. Out of that gallon of coating that you purchased, really, on average, you're only getting about 30% of that gallon on the part. If you'll notice, the filters behind on the floor, and his clothes are pretty dirty, so there's the other 70% of that gallon you paid for. Whereas on a flatline spray machine, because of all the factors we just previously talked about, of the uniformity of the application, we can get a transfer efficiency of about 60%. So great, we were saving coatings and saving money. That's important, obviously, but that's not the biggest factor. The biggest factor for your return on investment is the labor savings that you will realize. So we know a standard kitchen consists of roughly 300 parts to that kitchen: face frames, drawer fronts, doors, shelves, end panels, whatever that may be. And let's say one day or one shift equals 8 hours, and labor rate of $25 an hour. You know, that may be a little high. It might be a little on the low side, but that's just kind of what we're using right now. Knowing from past history of customers, a shop that has 3 people in their spray department, it'll take them 3 days to finish those 300 parts. So with labor rate of the $25 an hour, you know, that equates to $1,800 in labor just for that kitchen. Now we're going to have those same 3 people in the same labor rate, but we know with a flatline spray machine, instead of taking 3 days to do that job, we can do that job in 4 hours, and we can do it more uniform of finish, more consistent of color than what can be done by hand. So with that labor, we're looking at $300 of labor to do that same kitchen. And you freed up 2.5 days for those 3 employees to do other things, go, you know, help manufacture the material. Or if you have the capabilities to increase the number of kitchens you can produce, then, you know, one kitchen is going to give you a savings of $1,500 just in labor. If you can produce more, obviously, then that's helping go back to pay for that, your investment of your spray machine. So this is the main reason. Obviously, quality. Since you're having a more consistent finish, then your quality to your end customer is going to be much better. That's hard to put a dollar amount on that. But if you're having issues by hand spray, you have a lot of repairs that have to go back, or runs or dry spots. A flatline spray machine can eliminate those as well. It's just hard to put a price tag on what that is. But so basically, that's what I've had prepared for you today. I hope you found that informative.
Thanks, Doug.
Yep.
We appreciate you sharing that with us. I just want to ask you a quick question before I open this up to everyone else. And again, just a reminder to attendees, if you see the Q&A button at the bottom of your screen, feel free to submit some questions for Doug there related to flatline finishing in general, any specific questions on belts, arms, or pressurization. He'd be happy to take those. But one I have for you, Doug, just my own, is what type of manufacturer, or in this case, a stylist customer, what type of manufacturer can benefit from a flatline finishing process?
Well, if you're spraying currently, if you have spray booth or two booths, and finishing always has the potential to be problematic, then we can eliminate those majority of those problems with the spray machine. If your goal is improved quality, then you're definitely a candidate. If your goal is to get more production out, then you're definitely a candidate. And obviously, those both go hand in hand. We can improve quality plus also give you a much higher production.
Thanks, Doug.
Mm-hmm.
A quick return to our conversation on self-cleaning belts quickly. We had a question come in while you were talking earlier about the cost of a replacement belt for something like this. And we were fortunate, one of your colleagues, Dennis Eckelberger, another member of our finishing group, was able to respond between $2,000 and $3,000, depending on the size of the belt. Can you confirm that and maybe talk about the process that goes to replace that belt? Do we need a technician to come out and do it? Is it something that the customer can do themselves?
Well, we send the apparatus to where the customer could do that themselves. We would recommend our people coming out and doing that, at least for the first time. But yeah, that price that Dennis gave you is correct. And it's not as complicated as it may seem. The machines are designed knowing we've got to replace these belts at some point. So I would say I would schedule at least 3 to 4 hours, maybe a little longer, to change those belts out. And but I think the customer could do it on their own, but we would definitely recommend personnel on the first 1 or 2.
Okay. I see we have another question that came in here. What happens when you need to stop the machine while it is spraying? I'm guessing this is for type of emergency stop scenario, or if something's going on. Can you pause the machine for that kind of immediate service work if necessary?
You can. It's not always the best scenario, but you can do that. Better if
So
you can
pausing is something that we can tackle, or pausing is something the machine is capable of doing?
You can, but it's best if you can let those parts that's already going through the machine, let those finish, and then turn the machine off.
Okay. Had another question just come through here, Doug. What's about a price difference between a 1-arm machine or a 2-arm machine? Just in average pricing for something like that.
Yeah, typically you're going to see that a 1-arm spray machine will be slightly less expensive or a little cheaper than a 2-arm machine, in the range of maybe 15 to 20,000 difference possibly, but it all really depends. You can get a 1-arm machine on a smaller body machine, or a 2-arm machine. Really, there's more things than just 1-arm or 2-arm. It's what's the size of the body of the machine? Is it pressurized or non-pressurized? So there's more things to consider than just the 1-arm or 2-arm. One of our best machines on the market is a 1-arm spray machine for customers for kitchen cabinets, let's say. And it's a robust machine, but it's 1 arm. If 2 arms is what you're considering, I would think it would be if you were more into a higher production setup where you want to run that line speed a little faster.
Great, thanks, Doug. I'll give just a couple more seconds here if anyone wants to submit a question for Doug to answer here live. If you would like to take the conversation with Doug offline, we encourage you to contact him via email. You can see his email there, dmounts@stylesmachinery.com on the screen. Feel free to send him any questions specific to your own process that you're currently using. Maybe you're currently a manual sprayer and looking to make that transition, and Doug is someone that can help you discuss those options. Doug, we do have one last question that just came in here. Can these spray machines that you've been discussing, can they be equipped with curing or drying cells? I guess we're looking to do a full process from start to finish. Can you do the drying components attached to this?
Oh, sure. Now, a standalone spray machine is going to give you your consistency and your production numbers. But obviously, we can add inline ovens to dry your coating. So when it comes out off the end of the line, that material is dry, it's able to handle it, able to sand it. So yes, definitely, you could always start with what we call a standalone spray machine, get that uniformity, get the production numbers, and then as drying becomes your bottleneck, we can add ovens to that to address the drying situation. But definitely from a one-arm spray machine, from a standalone spray machine, all the way to a complete full line with ovens and panel flippers, we can do the whole range.
Great, thank you, Doug. And for those of you that are attending in this web session, just a reminder, this is our product specialist team across the country. So locating where you are on the US map here, we also have services provided throughout North America, but these are the three members of Doug's team. You see he mentioned the South, Central, and Southeast regions there in red. In the Great Lakes area or Northeast region of the country, you're going to want to talk to David Greer. And if you're on the West Coast, we recommend you contact Munir Idris. Again, our finishing team is ready and equipped to answer any questions you have, perhaps about what kind of full system we can set up or customize for you, from a standalone machine through a full system. Doug, I want to thank you again for joining us and sharing your expertise with us today. We're happy to have you being a valued member of our team. If you need to contact Doug, his email information, dmounts@stylesmachinery.com. So a couple quick notes before we end today's session. At Styles University, we are currently offering a free 7-day trial for our online learning platform, Styles University Online. You can find more information on this platform that allows us to bring the expertise of our faculty and our adjunct faculty right to you wherever and whenever you need it. If you want to find more information there, please visit the website on your screen, www.stylesuniversity.com/SUO. There'll be a small form to fill out at the bottom of that page, and we can get you that 7-day trial starting as soon as today to get you exploring and seeing what courses we have available there. You can also email us at classes@stylesmachinery.com for more information about our in-person classes that we hope to resume as soon as possible. And lastly, just want to make a specific announcement for our upcoming Manufacturing Solutions Seminar. It is coming online for the first time in its history. This one-of-a-kind event has inspired thousands of in-person attendees over the years, and it's digital, bringing unique technology experiences, fresh business growth ideas, and engaging networking opportunities directly to your screen. This event will be held the week of May 18th through the 22nd. Doug will actually be returning to host one of those sessions during the week, a continuation of what you saw today. You can find details for the seminar and a full schedule available at the website you see on your screen there, stylesmachinery.com/MSS. Registration